Hi, today we are going to see about the external conditioning method. There are so many external conditioning methods are available. Among them, first we are going to see about the zeolite process. Before we get into the topic, let us see what is external conditioning. When we treat the water out of the boiler is referred as the external conditioning. In zeolite also, we are treating the water out of the boiler. That is also the zeolite is come under the external conditioning method. The zeolite process is also known as permuted process. The zeolite is a hydrated sodium aluminum silicate and it's capable of exchanging reversibly its sodium ion for hardness producing ions into water. This is the structure of sodium zeolite and it contains micropores. There are two types of zeolites are available. They are natural zeolite, another one is the synthetic zeolites. The natural zeolites are non-porous at nature, so we cannot utilize this for the external conditioning. For natural zeolite, we can say natrolite is the example. In the synthetic zeolite, there will be porous and also it possesses gel structure. This plays a vital role in the external conditioning. They are prepared by heating together China clay, Bellspar and then soda ash. The zeolite possesses higher exchange capacity per unit weight than the natural zeolite. Now let us see the process. The hard water is percolated at a specific rate through a bed of zeolite kept in a cylinder. The hardness causing ions are retained by the zeolite as calcium zeolite and magnesium zeolite, while the outcoming water contains sodium salts. Let me explain the removal of temporary hardness. Already we know these salts which are responsible for the temporary hardness are calcium bicarbonate and magnesium bicarbonate. When we pass the temporary hardness causing salts containing water, when we pass over the sodium zeolite, there will be exchange process takes place over there and there will be formation of calcium zeolite. The sodium exchange its zeolite with the calcium, then it converted into a calcium zeolite and then there will be formation of sodium bicarbonate. In the same way, the sodium zeolite combines with the magnesium bicarbonate and there will be gives out of magnesium zeolite as well as sodium carbonate salts. And then let me explain how it removes the permanent hardness. We know the salts which are responsible for the permanent hardness. The salts which are responsible for the permanent hardness are calcium chloride, magnesium chloride, calcium sulfate and then magnesium sulfate. When we pass the water containing permanent hardness salts over the sodium zeolite, there will be exchanging property. So the calcium is converted into calcium zeolite and there will be formation of sodium chloride. In the same way, the magnesium chloride is changed into magnesium zeolite plus NaCl. Look at this. This is the zeolite process apparatus. Here when we pass the hard water over the zeolite bed and there will be exchange processes takes place over there. The zeolite is converted into calcium zeolite and magnesium zeolite and there will be giving out of soft water. And then if the resin which is available in the zeolite is exhausted, that can be removed with the help of NaCl. When at this stage the supply of hard water is stopped and then exhausted zeolite is reclaimed by the treating the bed with the concentrated NaCl. So the zeolite, that is exhausted zeolite, is combined with the brine water, that is NaCl, and there will be a formation of a sodium zeolite. So now the sodium is combined with the zeolite. So this is referred as the regenerated zeolite. So in this way we can regenerate the zeolite, and then now it's capable of exchanging sodium ion with the uh, hardness causing salts. In this way we can regenerate the zeolite. Now let us see what are the limitations of zeolites. If the water is turbid, then the turbidity causing particles clogs the pores of the zeolite and make it inactive. This is the main disadvantage of this. And then next, if the water contains ions such as Mn2 plus and Fe2 plus, it forms stable complex with the zeolite, and then which cannot be regenerated that easily, as both metal ions bind strongly and irreversibly to the zeolite structure. So this is the another disadvantage of zeolite. And then any acidic present in the water, it may be acidic water, should be neutralized with the soda before admitting to the water to the plant, since acid will hydrolyze the silica dioxide forming silicic acid. So we have to before we take the acidic water in the zeolite process, we have to neutralize the water. Then only we can use the water in the zeolite process. If the acidic water, when we convey this in one word, the acidic water cannot be treated with the help of zeolite process. Thank you.